Last February, Ada and Isaac and I went hiking up Rabun Bald, and while I was there, I noticed all of these crazy trees and how they were growing in strange ways. They were going up and then they'd slope back down, and they reminded me very much of some of the quadratic functions that we were learning about in class at that time. Before the hike was over, I had come up with this whole little metaphor in my head about how trees could be used to explain intervals of positive and negative and intervals of increasing and decreasing. So I'm going to explain that metaphor to you in video 3, but for now, let's go ahead and get to the notes so I can tell you exactly what I'm talking about when I say intervals of increase and decrease and positive and negative. Welcome to lesson 3.5. We are going to cover intervals of increasing and decreasing as well as intervals of positive and negative. In this first video, though, we are going to talk about intervals of positive and negative. So, as I said, the learning targets for this is that you're going to learn how to identify the section of the graph over which the function is increasing, the section over which it's decreasing, and then the section where it's positive and negative. So, let's start with this positive and negative. As you would guess, the section of the graph that's positive is going to be up here above the x-axis. So when we're talking about positive, we're talking about the y output. Is it a positive y value or a negative y value? So the notes over here, the positive regions of a function are those where the function is above the x-axis. It is where the y values are positive, not 0, but positive 1, positive 2, and so on. So that's going to be up here on your graph. The negative regions of a function are those where the function is below the x-axis. It's where your y values are negative. Again, not including 0. So on your graph over here, that's going to be this section below the x-axis, because if you think about your ordered pairs, below the x-axis, you're at 1, negative 2. You're at 3, negative 4. So those all have negative outputs. When you plug in x values, you get negative values out. And so that's where the function is considered negative. The last region is on the x-axis. Values that are on the x-axis are neither positive nor negative. This is where y is equal to 0. And 0 is kind of a bridge between positive and negative numbers. So let me show you a couple of examples kind of how this works. Sometimes you will see a function that is going to be positive over the entire domain. That means no matter what x value you plug in, you will get a positive y value out. So when I plug in 1, I get positive 2 to this exponential here. When I plug in 3, I would get positive 8. You can't see it on the graph, but it would be up here. When I plug in negative 4, I'm going to get 1/16. Which is very tiny, but is still positive. So because this exponential has an asymptote here at y equals 0, it's never actually going to get to 0. Therefore, it's going to be positive for its entire domain. You can write that as negative infinity to positive infinity. You can write it as all real numbers, or with really with any of your notations that you like. But you will use less thans because it's never gets to infinity. Some functions may be negative the entire time. If this exponential curve had been flipped over, if I had put a negative in front and reflected it over the x-axis, then I would have had to say that it was negative across its entire domain and never positive. So here's an example of a function that is negative across its entire domain. There is never a point where this quadratic goes into the positive region of the graph. This would be a quadratic that's been reflected over the x-axis, has been shifted over and down a bit, and so now I can say that it's a negative function across the entire domain, because no matter what I plug into this function, I'm going to get a negative number out. Again, I didn't put equal to there because it never actually gets to negative infinity or positive infinity. Now, most of the time, well, I can't say most, I guess, but often the functions are going to have both positive and negative regions. So it's going to have a section of the graph that ends up being above the x-axis, and then a section of the graph where your y values are below the x-axis. So in this one, this section starting here and going up, that is the section of my graph that is positive. If I want to write the domain for that, I'm going to say starting when x is 0 and going on to infinity, this thing is positive. Now, you are not going to include 0, not because the function will never equal 0, but because at 0, the output is neither positive nor negative. At 0, the output is 0. So you would say that it starts being positive at 0, and everything just past it, 0.001, is going to give you a positive output. But you're not going to include that 0. At the same time, your negative section is going to be down here below the x-axis. So that happens everywhere that x is less than 0. As I plug in values that are negative, I get out values that are negative. Again, I did not include that 0 because that is the point where it's equal to 0, and that's neither positive nor negative. Remember, when you're finding intervals, you are only going to be looking at the x values. Be very, very careful. When we're asking about positive and negative, we're wanting to know over what portion of this graph, what x values can I plug in that will give me a positive output? What x values can I plug in that will give me a negative output? So you're giving me the domain over which it's positive and the domain over which it's negative. If you need a refresher on how to write those intervals, go back and look at video 2 from lesson 3.3, because that's where we first introduced that. All right, you guys go ahead and try a couple of examples. I've already got a little bit of highlighting there for you. But you guys can try number 1, 2, and 3, and then check your answers, and I'll see you in the next video. Bye.